Welcome back to Gabversity, where facts care not about your feelings. They don't care about yours, they don't care about mine. Facts don't care about anyone's feelings. Alright, so fingers crossed you are all asleep. You better be asleep. Otherwise, I shall be very upset with all of you. So, let us begin. We are going to talk about the Dirac function. Oh, I just said I hope you're asleep, but Boss Briggs does not sleep. The woman is a machine. Just like her what do you call it? Her politician, the man himself, Trump, never sleeps. Boss Briggs never sleeps. Amazing stuff. So we're going to evaluate some integrals, and the Dirac function is a step function. We've already spoken about this in one of the other lectures. And what it does is it allows you to look at one strip of the wave function at some location. As we said before, we get the area of like a rectangle, and we keep the same area and we squeeze the sides so that the strip upwards goes to infinity, but the area stays the same. Just as a recap, it looks like we have no one here according to Gabversity. As a recap, as I said, what you can do, right, is imagine if you get a square and then you push inwards on either side, right? If you do that, it's going to turn into like a rectangle, right? But with the same area. So here, the area equals A1 equals A2, and this is A2. All right. So we're squeezing and squeezing and squeezing. Now, in the universe, this can't happen, but in mathematics, this can happen, where it turns into this, and this line goes for infinity, and that's A3. And so now, A1 equals A2 equals A3. Right? And that's pretty damn awesome. So you can get the same area. And there's a mathematical reason for that, which I explained in the Dirac equation. So now I'm going to show you some integrals, right? And it's brilliant because it allows you to solve some integrals much easier. This is +1 and this is -3. And we're going to say, here is the actual integral. It's x cubed minus 3x squared plus 2x minus 1. All right. And now we've got the Dirac function, which is right here. This is the step function. Okay. There it is. Looks like a musical note. It's a delta. All right. Now, what's awesome about this is that just equals f of a, right? Now, the rule is this. This thing here is f of x, right? In other words, it's a function that does something to x. It makes a big polynomial equation. And this here, right? This here is x minus a. Alrighty. So now, the rule is that when you get a Dirac function, okay, when you get a Dirac function, the rule is this, that the integral of that, integral of fx, that f of, so Dirac of x minus a, right? Franzman, right? This equals f of a. Hey, thank you very much. This is the rule. So the rule is that you take the negative of this number and you chuck it into this function. That's the rule. That's all it is. So all we have to do is take the negative of 2, which is -2, and we put it in here. So that means that this is going to equal -2 all cubed, because we have x cubed, minus 3x squared, which will be minus 3 -2 squared, plus 2 by -2 minus 1. Right? There it is. So all we did, just to be very clear on what I'm doing, right, is we took the negative of that, which is -2, right, which is the Dirac of x minus a, right? It's x plus 2, so clearly that's a negative. Okay. And because, so if that's a minus a, we take f of a. So obviously if that's plus a, we take the minus a. That's it. Okay. And then we chuck it into here. So we get the minus a, right? And we put it in here. So a cubed, so like minus a all cubed, and then a squared, like minus 3 times a squared, blah, 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 blah. And there it is right here. So minus 2 all cubed, minus 3, and then minus 2 squared, plus 2 times minus 2, minus 1. That's it. And that equals, well, that's minus 2 cubed is minus 8. And then that's going to be minus 12, should be, because 2 squared is 4 by 3. And then this one here is minus 4, and then minus 1. And that's 8, 12, 20, 24, 25, minus 25. So what we've done is we've figured out that the area, right, the area that's created by this squiggly thing with this step function gives you minus 25. That's the area. That's it. That simple. Right. Why is that important? I've mentioned before that that is important because we can use it to simplify a wave function at a certain point in time. Yeah. Yes. All right, sounds good. All right, Gabversity has to wait because I'm going to go sit and say hello to Mum for 10 minutes. Lovely to see you all, and don't forget, facts don't care about your feelings or my feelings. So let's get gabbed.